everything's coming through. Cool. Okay, so last night, or yesterday I should say, I made some progress on the VMViz project. So we just have some static memory maps here. We can zoom in all the way into individual bytes, pages, bytes, cache lines, pages, and maps with dividers there. So what I wanted to do is start reading maps from processes directly. So I'm aware like procpid maps, obviously. Like you can read from there. The information we're going to display is obviously the range, permissions. So read, write, execute, protection bits. I don't know what P means here. It's on every map, so I'm guessing that's just like a protection thing. Maybe that's whether protection is enabled or not. I don't know. What else we got here? I don't know what this thing is for. This is device ID. Like the backing device ID. Like obviously, like if it's zeros, that means it's pure memory. But if it's a device ID, then it's going to be device and then inode number. So you can see these all have the same inode number. Same thing here. What is this locale archive? I wasn't familiar with that. It's interesting. I guess that's because it's cat. Yeah. Yeah, VDSO, like all this stuff that they don't have device IDs. This is probably heap, even though it doesn't say heap, because heap memory is a specific segment from the binary information, I believe, whereas these are probably like created at runtime, is my guess. But they look very much like heap, just anonymous memory maps. Anonymous private memory maps. That's what those look like, without the execution protection. VVAR, vclock, VDSO, vsyscall, these are all things that the kernel maps in. And then this is obviously the dynamic linker. And then I don't know what this is. This is obviously stack. This is close to the stack. So it might be, I mean, it's close, but it's not super close. It's closer to these other anonymous memory maps. So this might also be like a heap slab or whatever. But yeah, I guess not a lot of information to display. I guess some questions I have is, what does the P mean? What is this thing? This is inode, this is device ID. So what does this say here? What does P mean in the protection bits? Why is it there? What does it indicate? And then what does the hex value next to the protection bits mean? For example, oops. Offset. Okay, that makes sense. P is a private mapping versus, yeah, a shared mapping. Yeah, alternative S for shared mapping. Okay, I don't need any more information here. Where can I get map information from a process that is easily readable from, excuse me, from C? Parsing proc PID maps sounds like a bunch of needless work. However, there are much cleaner options than hand parsing text yourself. DL iterate program header. Best for loaded ELF objects. No, don't want to do that. I want a PID. Procfs parsing, what almost everyone does. Canonical source. Scanf. Okay. VM region style APIs do not exist on Linux. So that is a mock API. There's also procpid page map. Proc self page map. What is that? Doesn't seem to want a cat. S maps. Procpid map files. What? Live crypto, why would that be in cat? Oh, it's because it's bash. It's not ls. Or maybe it is ls. Yeah. Okay. Because if I do here, if I say ls self, and then I do something like command, isn't there a command symlink or something? exe. It's a stupid easy A thing. I don't like that that's on the system. Okay. Okay, give me some code here to parse the maps file. Jesus. I don't know why, as soon as I start streaming, I just start sneezing and get really congested. It happens almost every single day. Alright, so we're not going to need this stuff here. So what I'll do is I'll pull it out and have a function here, just call it void register test maps, and then put that there, and I have to pass in the register, which is a pointer to a map registry T, which means that I would be passing in the pointer directly here, and then here create my registry. I'm gonna say register test maps from, I give it reg, or sorry, pointer to reg. Cool. This stuff I'm gonna pull out into our debug.h. Oops. And that is gonna need map.h. There we go. And if we look at map.h, it's got the if and def, so that's good. All right, we can do a make here now. Everything should work as expected. Boom, boom, boom. Whoops. Hey, doesn't look like it's working. Odd, that is odd. Okay. Why did that decide to not work all of a sudden? And none of this stuff responds at all either. Huh? Huh. Yeah. Got into raylib, created the window, went into the draw loop. Is the draw loop drawing? Not even drawing this text up here. Seems like it's frozen on something. Yeah, it never exits draw maps. Let's see why that is. So we take in our registry. So cur probably never hits null. We'll do a %p here. And give it cur. And previous. Sorry, need to make it. So we went into previous cur. So we go into here. The previous gets assigned. If cur is equal to null, then we continue. Oh, it's a continue. We would continue to up here and then we would break. So that's fine. I mean, I kind of feel like that should be a break, but whatever. And we get stuck somewhere after the second iteration. So we're on the second iteration. We have our current, previous, printed out. Then this draw map thing, maybe that's the thing that's being blocked. We'll just say puts done draw map. And we'll put that after here. We'll kill and rebuild and yeah, we never finished drawing the map. Odd. It's all very odd. Puts here, done, drawing pages. Here we'll just say drawing pages. Yeah, we get stuck in this loop here. Pages. Let's see what that is. Pages. Actually, let's open up our thing here. So we're not pegging the CPU. Actually, we are. C7 is at 100%. Yeah, it's bouncing around different cores, pegging it. So it's just drawing pages over and over again. Let's see what this value is. If that's like a huge value, then that might be why. What is pages? LD? Yeah, it's a very big value. Wonder how that got there. So we got pages, which is the map length divided by the page byte size. So if we go back to our what is this, debug? So something happened with size of second buff, because that's what determines the length. I mean, they're all the same size. Printf out len of 1 percent LD new line size of first buff. Oops. Second buff, third buff. So it'll be up here. Would it? Yeah. So the lengths are all 1 meg, which is what we expect, but then we get this huge pages value out. So maybe something's messed up with register map, because that length should not have happened. Let's go down here to draw again, and we're gonna print out the map length. Map length. Map length. Yeah. Yeah, it's coming out as 0 and like some insane value. So these are garbage values. If I run it again, it'll be a totally different value. So map length, map is a map t. Map t is defined here. Length is a size t after buff. And then if we go to the debug, sorry, debug.h, our register map, sorry, this will be map.h, or map.c I should say, and it's gonna do all this stuff. It's gonna print off, printf. This will be map start, map length, map remote adder, and we'll add map next, even though it's not populated yet. We'll just call register map, new line, give it start, which would be a pointer, I believe, length, which would be a LD, remote LD maybe, and then a pointer here. Okay, that's doesn't like that because why? Int, what is start again? Sorry, let's go map t. Sorry, it's buff, not start. Buff. And if we go back here, it's a uint 8t, a size t, a uint pointer t, and then a struct map t. I think all those should print out fine. So let's go back over here, kill this. Alright, that did not come through correctly. Printf because it's not included. I'll need to remove that at some point. So I'm just going to say remove me. There you go. Alright, now if we go back up to the registering, okay, we're registering with the same, different addresses, 789 here. The lengths are okay, remote adders are okay, everything's okay here. So something happens when we're iterating. Draw.h, I'm gonna just delete this since it's not needed. Well, I'll leave it for now. I just won't commit it. Let's go to draw.c, kill this, kill that. Alright, what's going on here? Where do we call draw map? Because it seems like the length is messed up by the time we call draw map. It should be here. Okay, what I'm going to do is load up the map.h, or c, grab this printf again, and I'm going to do that here. So right before I draw the map, I'm going to print it out, and the map is cur. Sorry, I don't want to call this register map. This will be a print, or say map. Yeah, we get negative values. And up here, it's all 5, 6 for the pointers. Down here, we get 5, 6 for the pointer. The length is 0, so it got corrupted somehow. This pointer is correct, and I'm sure this is correct because it comes down here. Maybe it's not correct. How is this pointer correct here, but my lack of skill in C is showing here. So let's go to debug.h. So we have this register map. The registry just has a pointer in it. So it's kind of like a pointer to a pointer. But we should say a pointer to a struct that contains a pointer to the first element. So our registry here, we say, hey, grab that first element. That's going to be cur. Okay, here's the problem, I think, is that we stack allocated those things. That's the problem. So in Go, which is what I'm most familiar with, when you do something like this, it'll do escape analysis and allocate it on the heap. If it's something that is escapes the function. And in this situation, we just have this struct that contains the first buff, the length, the remote adder, but we keep a reference to that struct. And so this has to live longer than the lifetime of this function. This function gets entered and we exit it, and the stack frame's lost. Whereas before we had registered these things, we put them on the stack, but the main stack never gets lost, the main stack frame, until the program exits. So that's the problem that we have here, is that we're using stack allocated memory that is lost. That's a tricky thing. For a Go programmer like me, which is used to like, oh, it doesn't matter if it's like this expression here, actually it'd be more like, it would be something like this. That could be stack or heap allocated. Okay, so we just need to malloc these things up before we pass them in, or we could put them in the data section by declaring them up here, but I don't think it's possible. Let's try it. So we're going to declare a map T. We'll just call it first map is equal to this. Okay, that works. And then can I just say buff here? Buff, sorry, dot buff is equal to uint 8t x No. I don't think we can declare those inline. I think we have to have it like this. First buff. Okay. And then basically it's going to be these fields here. So we give them a static lifetime. That's what we're doing here by putting them in the data section. So this is going to be second map and third map. Second map and third map. There we go. Alright, so that should fix things. We're going to have to remove a lot of the printfs that we added. Let's go to map.h. I'm sorry, map.c. Delete all this stuff. We're going to go to draw.c. Delete that for sure. Let's do a get status here. Get diff on source draw. So we got another printf there on draw map. There we go. What is the... Oh, there's some puts down here too. Puts. Yeah, there we go. Okay. Source maps.c. Just a map.c. Just do that. Cool. All right. So let's do our make. Cool. There we go. Everything works. Zoom, zoom, zoom. Cool. All right. So now we can do our actual parsing of the maps. The thing is that we want it to be done continuously, which means that we have to update the linked list. Okay, so we can make this a concurrent data, the linked list concurrent data structure by having a mutex on it. Or we could just have it updated in the main thread. Eventually we're going to have a separate thread, because you can't do all this work on the main thread. It's like, do we want to block the main thread potentially on a lock? Or, I mean, we could try doing a lock-free data structure as well. But do we want to block the main thread on a lock, or do we want to have the main thread do all of the work? I would argue that it's better to take advantage of the parallelization of having multiple threads to offload some of the work onto a separate thread, and then only pay the cost of blocking on a lock if there's some type of write that's happening from the secondary thread. So I think what we need to do here is say, okay, the registry now, it's going to need to have a lock, and I think we have to initialize these locks. So if I go up here, I'm just going to quit out of one of these buffers, and we go man on pthread rw lock init. Yeah, here we go. So I want to do an rw lock. Do I want an RW lock? Because I only have one reader. Is an RW, is a pthread RW lock more perform than a pthread mutex if you only have one reader? I don't think it is. Yeah. Yeah, so we're just taking mutex. Okay, so let's jump over to our register, or it's called map.h, map.c I should say. So we have a register map. Map.h is gonna have mu, which is a pthread mutex t, something like that. And we'll go over here and we just say mutex init. Yeah. So these are all the mutex things. What's interesting is this is in the standard library 3, but if I go over to here, it's in 3p. Let me do -a. Yeah, just in 3p. So read write locks are not documented in libc, or glibc I should say. They're only documented in the POSIX documentation for libc, and that documentation isn't great. Alright, so here we have mu is a, well, first I'll have to include pthread.h. And this is my goisms showing. Put in the type in the wrong location. So there's an initialization stage, and then you can lock, unlock, and a destroy. So we're going to have a thing here, which is registry init. And it takes in the registry, initializes it, and then registry destroy. Okay, so now we go under map.c, and if I go back here, I need to have these prototypes. So the job of the init is just to initialize the memory. So this is going to be a call to pthread mutex init, giving it the reg mu, and this thing here, which is pthread mutex adder. Mutex adder. Let's look at the documentation for that. Initialize mutex object pointed to by mutex according to the mutex attributes specified mutex adder. If mutex adder is null, default attributes are used instead. Okay. Let's go ahead and use the default, I guess. Null. Oops. Why is this complaining here? Pthread mutex init takes in a pthread mutex t pointer. Okay. You need a pointer to that. And then I imagine it's going to be very similar for the destroy. We do destroy. Oops. And you give it that. Bam. Destroy, yeah, it just takes the reference. And then here I can do something like where I guess I could do a constructor destructor like pattern, since I'm already doing the init and the destroy. New registry, del registry. So new registry will return a map registry t pointer, and then del is going to be a void, and then I can delete this. And then in here we need to do a malloc. So it's going to require this would be like standard lib.h probably? No. Where's malloc at? Man malloc. Yeah, standard lib.h. Size of map registry t, and this will be our registry pointer, which will be a map registry t pointer reg. Down here we're going to return reg at some point. Okay, so we malloc it up. We then dereference it, get its mu field, get a reference to that field, and then init that, and then return that. And then in del, I wonder if I should say del or free. New. In C, what is a common pattern for constructor destructor naming conventions? Something that calls constructor being a function that calls malloc, initializes the data and returns a pointer. Type. Type new, type free. Create, destroy, new free. Very common split in larger C code bases is init, dinit, paired with option create, destroy, init, dinit. You want to do the malloc free and init, dinit all in just two functions. Okay. Create, destroy it is. So we'll call this registry create and registry destroy. So we malloc up our registry. We then call the init mutex thing and return it, and then we destroy it. See, in create here we're doing malloc and init, whereas this thing separates the mallocing from the init. What is this? Let's read destroy. Okay. So there is no destroy or create. All right. So here we're going to say registry create. And this will be an auto now. And we're going to have to save map.h if that's not already saved. Oh, these are different names now. So it'd be create destroy like that. Okay, and then we just pass in the reg there. Okay. Start registry map monitor on reg. Void start map monitor on a map registry T pointer reg map.c, put it here, pthread create. Let's do a man pthread create. So we have to have the thread. The adder can be nullable. Start routine is just a pointer, function pointer, and then arguments is a pointer. So that's the actual thing being ran. But here we have our pthread create here. Tinfo, tnum, tinfo is here. Thread ID. tinfo. Struct thread info tinfo. Thread ID. Thread num. This is all stuff that's not part of the API. So pthread create. You give it a reference to the thread ID, the adder, start num. That's bizarre. This should be a reference to a pthread T. Is a pthread T just a thread ID? Pthread T. T. Yeah, it's just a thread ID. Okay. And it wants a reference to that, so it needs to be heap allocated if it escapes this function. Wait a minute, that says ID returned by pthread create. Oh, because it gets written into. Okay, that makes sense. And it does call calloc here, so they are doing heap allocation on this. So let's do a malloc of pthread T. And we'll just say, hey, sorry, size of pthread T, pthread T pointer is equal to that. I guess we could store that in the registry. So that'd be map.h, the registry here. Have our mutex, but we also want to assign into our thread ID. Pthread t. Okay, so that'll allow us to avoid this malloc. This will just be a reference to reg thread ID. Or just call it a T. T. Okay, so that fixes that. This can be null. This will be the thing that gets ran. Map monitor. And this will be a reg like that. And then we'll need a void map monitor map registry t pointer reg. I think it has to come through as a void star. I think that's why it's complaining. So this needs to be a void star. No? Oh, sorry, monitor. Then, yeah, it does need to be a void star. Huh? Why is this thing not moving? There we go. Void star needs to be a... Okay, so we need a reference to it? Oh. It returns a void star? Okay. Oops. And this cannot be a map registry T. Compiler doesn't like that. Okay. Void. Oops. There we go. Okay. Time.sleep, so just be sleep. Sorry, time. Sleep not part of time? Sleep is part of unistandard.h, which somehow gets included. Okay. Well, we'll just include it here just in case. Alright, so we have registry create, registry destroy, start map monitor, which does our pthread create and immediately returns. Then this thing is going to read procpid maps. Update registry. Sleep. Okay. There's some code over here that I had AI generate. Actually, it's over here. I need to regenerate it. There we go. I don't like using the file thing. That's fine. We'll just do a void for now. Read maps file. Was it? Did I not copy that? There you go. So we're going to need to have the PID, a pointer to some type of process state. So that's probably going to be a new header file, I would think. So include process.h, and then here, if we go to our map.h, and diff. I think it's that diff, right? Yeah. Here, we're going to say, hey, struct this is going to be process. In here, we're going to have a PID, tpid, process t, pound include standard lib.h, uni standard.h. I know PID t is in one of these things. Man PID t. systypes.h. There we go. Okay. So it's going to contain our PID. What else? Oh, that's all I need for now. So let's go back to our main. We're gonna, in here, create our, so we did this as a malloc. Why did we do that as a malloc? Because of the initialization. We really didn't need to do it as a malloc. I just wanted one function to call instead of allocating the space and initializing it as a separate function call. but it doesn't need to be heap allocated. So I'm kind of like wondering, like, should I just like init this thing and call it a day? I don't even think I need this anymore because I'm not gonna, I guess I have that debug thing that uses that. Okay, let's go back to main. This will be a map, what is it called? Map registry? Yeah. Map registry T reg. And then we'll have registry init pointer to reg. Sorry. And then we'll do the same thing here. Okay. Then we're going to need to do something with process T P, which calls a P proc. Process.h. The main thread's going to be handling input. And then sending that to this other process. So it's also going to need to be a init thing because it's going to need to have a mutex. So we'll say process init. And it goes like that. So process.h is going to have a void process init. This will be a process T pointer proc, and process.c here. Go back to map.c. We'll grab this guy here. Do our pthread mutex on that. And if we go back to process.h, it's going to need to have a mu pthread mutex t mu. It just needs to have pthread .h. Process.c is going to have process.h. And why is this? Oh, because we're calling reg instead of proc. Okay. Now when we go to our map.c, or map.h really, start, you're also going to need to have a process T pointer proc, which means that this is going to need to have process.h. And if we go back to map.c, we're going to have to add that argument here. And we're going to have some type of struct that we pass in here. And it needs to be long-lived, because this thing's going to return, so we have to malloc up a struct that has, sorry, we're going to have type def struct here. We'll just call this map monitor args, which is gonna be, we don't need static on that. It's gonna be these two things here. And then we'll malloc up, oops, size of map monitor args, map monitor args is equal to that. Here we say args dot, what's a pointer? This needs to be a pointer. Args reg is equal to reg, and proc is equal to proc, and then we pass in our args here. Now map monitor takes in a void star args is going to be a map. Pull this definition up here. Map monitor args. There we go. So you know our PID now, and we know our what is this thing complaining? Undeclared identifier process. Sorry, proc. There we go. So we have the memory for our PID and our registry, so we can do our reading. So the first thing I want to do is just copy out PID T, or we can just do this on auto PID is equal to, first we got to require the lock. So pthread mutex lock. We're going to give it the in fact, we'll do this as part of the PID structure. So let's go to process.h, and then here we're going to say process get PID, and this will return a PID T. And then we go into our process C. We'll have this, and then here we're going to do our pthread. Oops. Pthread mutex lock, giving it the proc mu reference, and then we'll do our unlock here, and then we'll get our auto PID is equal to proc PID return PID. Yeah. Okay. So now I have a guarded PID there. Let's go back to our map.c. This will just be process get PID with args proc. Yeah. We can copy these out. What we can do is we can say, okay, reg is pointed to map, so registry T args dereference. Then this has to have a type, which is going to be a underscore map_arg star. I think that has higher precedence, right? We'll try it out here. Reg, and then this is going to be proc process T proc proc. And then this will just be a proc here. There we go. And I think I can do away with this here. No, I do need that. Okay. Alright, so we got our PID. Now we can do our call up here to read maps file. PID T PID. And we'll put that in there. Moment read maps file PID. What are we going to read? Because each iteration of this, I'd rather it be stack allocated data. So I'm going to say read from, or say update maps from file. Update maps from file, give it the PID and the pointer to a map registry T reg. And we'll do a forever okay. And in here we're going to do our f open, and this is going to be our %d here. So char, we'll say file path array 1 to the power of 8, 0 initialized. Actually, we can initialize it to, yeah, that's fine. And then we say sn printf, so it'd be a pointer to, or you say file path here, size of file path, restrict char star will be our format here, and then our array will be PID. And then if we do a man of sn printf, should be return value on error negative value is returned. And then the functions do not write more than size bytes. Oops. So here we could do something like, oops, n, auto n. If n is less than 0, if n is greater than or equal to size of file path. These are two error cases. P error exits one, or we can say exits failure. And then we'll do a similar thing here, but we'll say fprintf, because I think p error goes to standard error. Yeah. So here we can say fprintf. We're going to say, or can I say fputs? That's what that. Man puts. Sorry, man 3 puts. Fputsy, fputs requires a string. Okay, we can do that. Fputs sn printf truncation in update maps for file. This would be standard error. There you go. Otherwise, do an fopen. Do our fopen on file path now. Read f and then man fopen. The return value. Null is return error node set to indicate. So we can say if f is equal to null, then we had an error. We can just do a p error of fopen. And then in here, we do our little scanf, start, end, perms, well, I'm going to zero initialize all this. Well, I guess that won't matter. Perms, offset, path. So you have 1, 2, LX, LX, start, end, 4S perms, yeah, another LX, and then 1, 2, 3 here. And we'll just do printf and we'll do an exit 3 here. Alright, let's get a test going here. fopen failed. I can't do that up here. Is there like a formatted version up here? Puts our file path. Whoops. So the problem is it's going to be a 0 or a random. Yeah. So here we need a 0 initialize this proc. Now it should come through a 0, in which case we should just abort. So here, if PID is equal to 0, or did we say if not PID, then let me just do nothing, sleep. Return, which will allow us to sleep for 2 seconds, and then continue. Okay, then we segmentation faulted. Wouldn't have expected that. Let's comment out draw loop. Okay. So it's definitely in draw loop. So our register is 0 initialized, so it should have null. Draw.c. Let's go to our draw loop. It's going to be this draw maps thing here. So I can comment that out. Yep. Previous current is going to be null. Here's where we dereference current. So there's an assumption that current is not null. I feel like this is that logic that I wanted to refactor because it just was like really weird. So in here I'm going to say, hey, let's just do that up front. That'll eliminate the need for this, and we can go up here. So we say if previous is equal to null, else. So we have 2 branches here. So this is the branch where previous is not equal to null. So if previous is equal to null, then we say, hey, if your remote adder is not equal to 0, then you got to draw a spacer. Because you're the first element and you're not at the 0 boundary. Else, that you do have a previous, in which case we're going to do some math to figure out whether we should draw a spacer. So really, I could express this kind of like this. Sorry. If previous is not equal to null, and because these are the same action, I'm going to do an OR here. So we do that, do an OR, and then do that, and then delete that. There we go. So it's previous is equal to null, and you're not at 0, or it's not equal to null, and I don't think we need these parentheses because OR has the least precedence out of the OR and combo. So I think we can get rid of those. Okay, there we go. What is this thing freaking out about? Get clock get time. Clear is able to build. Maybe not. What happened? Get diff on what file is this? Source draw.c. So I include a Unix standard for some reason above default source. All right. There we go. And just to make sure this stuff is working here, if we go to our map.c, so here we do a return. I think what we should do here is include a debug. .h map, test. What was our debug.h? Register test maps. Okay. This is where we need to do our pound define, yeah. There we go. Okay, how do I do this again? Map.h. If ndef debug h, define debug h. These are the same thing, and then endif. So it should only ever exist once. And yet it's freaking out because why? Oh, these are different object files. Okay, that makes sense. Well, let's go ahead and just do edit source debug dot C. Let's quit out everything. mv source debug dot h into source include debug dot h. Vim source debug dot c. Alright. Debug c. And then over here, debug h. I think this needs to go into debug c here, and we'll pound include debug.h, and then up here we don't need this, I don't think, right? Yeah, we do need it because of the implementation. We need that because of the rectangle. We don't need map. Map would be here. There we go. And then in here, define printer. We also need a define printer header. Headers. Header, which would just not have any of this. It'd just be like that. Define printer header, type fields, type. We don't even need the fields. Say, hey, type. Header. And then this stuff would then go into here. Oh, and I don't need this. Okay. There we go. Okay, so that'll do that. Okay. Make. Alright, so now we got some warnings. We can fix up map.c. Debug h. Oh, I also need to go into debug.c and grab this, register test maps, and put it there, which will necessitate a pound include on map.h. Alright, so that'll fix that. Hey. No such file directory. Oh, we do need to return. So let's go back to our process.c. No, what was this? Map.c. And then here we do that and return. There we go. So this is going to add a bunch of maps. Oh wait, that's weird. I think the issue that we ran into there, if I'm not mistaken, is everything froze. I think it's because we're trying to acquire a lock, maybe? Here, we'll do printf. Okay, so register test maps. Here we do need to acquire the lock. So anywhere we're using the registry, I should say, we need to acquire its lock. So here, that's just creating a thread. Okay. So here we have to say red or reg mu. We're going to say pthread lock. That. We can do that down here. I want to do that just in register map. Here. Yeah. So mutex. Okay. Just froze. We got a register test maps up there. And then date maps from file here. Okay, we go into the register test maps. It's doing this initialization stuff. I feel like this should only happen once. Is there, I think there's a pthread once, right? Man, pthread once. Yeah. So it is void to void init routine. It's a weird signature. Because this is the beginning of the arguments, that's the end of the arguments. But then it has this init routine here. I feel like the documentation should have that inside the argument tuple. Okay. Init test maps. Oops, not as a call. There we go. So called init test maps. So it's not having a problem acquiring a lock. It might be that it's not. Okay, so we have a data race. It's not acquiring the lock on the other end. That might be the issue. Okay, let's go over to anywhere that we're calling or dereferencing register. Let's go to draw.c and look for, I'll close out of that. Reg. So here we need to have the lock, the draw maps. So this will be pthread, mutex, lock reference to reg mu. And then we'll release it over here. It's still that second one that's freaking out. Rip grep for reg mu, or sorry, just reg. Okay, so in draw we are guarded by lock unlock, and then this is guarded by lock unlock as well. Pthread create was in the start routine. Okay. So it's not a data race. It's just freezing. And in freezing, it's actually freezing the whole frickin' thing, including the drawing. Which is odd. That means both threads are blocked. Which is why I thought it was a data race. Okay. Oh, it's because it does like an infinite loop. Because in the debug.c here, these are static, and so when we update there's a hidden pointer here next. When we register, we update those pointers, and then the next time we go around, we're basically creating an infinite loop. Where the last thing here is pointing to null, it's then going to point to the first one, and then we get stuck into an infinite loop. On the second, yeah, it makes sense why it gets stuck there. And since the lock's acquired, we never unlock it. I mean, I would have thought that it would have deadlocked the main thing because I didn't have the locking in place. The main UI thread, I don't see why it would have frozen because it didn't need the lock. Or it needed a lock, but I wasn't acquiring it. It was a data race. But I guess as soon as I do that update, it also gets into an infinite loop. That makes sense. So basically this whole thing has to be here. Or we dynamically create the maps, creating garbage. Or we can have the register map look to see if it already exists. That might be a nice little thing to have. So that'd be in map.c. We go to register a map. We say, hey, we're going to register a map. We take out our lock. And then we're going through trying to find cur. If cur value is not equal to null, and cur val, we'll say if cur val is equal to the thing that we're adding, which would be our map pointer, the pointer itself, then we can just return because you're already in there. Oh, but we have to release the lock. Yeah. So any early exiting here, we gotta release the lock. I like that. Alright, let's try that. That should work. Yeah. Now we can remove all these puts. delete that. We need the f puts. Need that. Oh, this should be f puts as well. To standard error. Okay. Let's try that. Hey. Okay. I thought f puts, does f puts not put a new line? Without its terminating null by puts right and a trailing new line to standard out. Okay. So f puts does not. So we have to f puts, have to add your new line. File path. Okay, there we go. All right, and then in our main, we will need to load this thing, parse arguments, and load it. So here we'll say parse args go ahead and split here. I'm going to go edit include, sorry. Edit include, why is that not? Include, yeah, I guess we don't need this debug.h anymore, right? Edit include args.h. args.h. Then here we'll have a type def args t, which will be a struct, and pid t. Pid be the only field we need. Pound include sys types.h, and we'll do the little dance here where we say pound if and def pound if and sorry, pound if and def underscore args h define underscore args h and if. Okay. And then we need to say void parse args, and we give it a pointer to args t. And then if we edit our source args.c, we'll have our thing here, and we'll pound include args.h, sorry, string args.h. And we also need to have our argvrc, so that would be main For some reason my completion's not working. argc argv is a char star array, like that, I think. And argc is just an integer, right? I think so. So these also need to go in here. And then we go over to args.h and update that. Alright, and then I need to pass in argc and argv. Hey. And then in here, we're going to have our parsing of a PID, which is just say if argc is greater than 1, then args PID is equal to this will be a libc function here, a to I think, man3 a to I, or a to L. Is a PID-T, what type is that? Let's go here. How long is that? PID-T. I don't think it's that big. There's not that many PIDs. A to I. Arg V sub 1. Yeah, because 0 is the command. Yeah. And then here we also need to include that header, which will be standard lib.h. Bam. And we can probably do without these braces. Okay. So that gives us our test maps. But if I do what's a, I guess I can do like $. Yeah, it's conserved. So I can do $, here, right? It's still 0? Oh, because they haven't updated. Yeah. So now in here, process init, and proc dot PID is equal to args dot PID. Bam. Okay. Now we're back into our parsing code, which is under, forget, process maybe? No. Oh, can't be draws, map.c. Yeah, over here. So we get our exit status 3 here. Okay. So while we're scanning in, we print out everything. It looks like it's doing the right thing. Start end perms. Let's say start end perms offset and what was this thing called? Path. Start and perms offset path. Alright, well that'll be enough to create the maps, I think. So I'm just gonna comment that out. To do add maps to registry, consider memory use or memory lifetime. Okay, I am going to take a quick bio break. When I get back, I'm gonna add all these things to the maps and see if I can get it displayed. Cool. Be right back.